assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this question, we have two spheres, A and B. Okay, and then each of them has 5 microcoulomb charge. They were connected by non-conducting string. Okay, so and the distance is 1 meter. Okay, so this distance is much larger than the radii of the spheres. So there are 3 parts in the question. We want to find out the electric potential energy of the system, find the acceleration of each sphere when we cut the string, and then what are the speeds of the sphere after a long time. Okay, so in part A, okay, so to find the electric potential energy, okay, we'll be using U equals to Q1 Q2 divided by 4 pi epsilon naught R. Okay, so the Q's are the same. Okay, so we have Q squared over 4 pi epsilon naught R. So we substitute the numbers, 8.99 times 10 to the 9. Okay, 5 times 10 to the negative 6 square, then divide by 1. Okay, and answer will be 0.225 joules. Okay, so this is the answer for part A. Then in part B, when we cut the string, okay, we want to find the acceleration of each sphere. Okay, so just to note that mass of A is 5 grams, mass of B is 10 grams. Okay, so to do part B, okay, we'll be using Coulomb's law to find the electrostatic force. Okay, electrostatic force is Q1 Q2 divided by 4 pi epsilon naught R squared. Okay, and by Newton's second law, right, F net equals to ma, right? So look at the two spheres A and B, right? The two forces are acting away from each other because they have the same charge, so they repel. Okay. Okay, so the acceleration of ball A, okay, of sphere A is going to be F divided by ma. Okay, so this is q squared divided by 4 pi epsilon naught r squared divided by ma. Okay, so we substitute the numbers. Right, so when we do this, and we get 45.0 meters per second square. Okay, and then we repeat the steps for AB. Okay, for sphere B, and this is F over MB. Okay, the force is the same. Okay, so we can just calculate. Okay, and you get 22.5 meters per second square. Okay, so this is the answer for part B. Okay, okay, then after a long time, okay, after a long time, we want to find the final speeds of the two spheres. Okay, so in this question, we have two conservation laws. Okay, first, we have conservation of energy. Okay, which says that U equals to half ma va square plus half mb vb square. So all the potential energy goes to the kinetic energy of the two spheres. We also have conservation of momentum. Okay, which says that 0 equals to ma va plus mb vb. Okay, so we can get va or vb to be negative ma divided by mb times va. This is actually half va, right? So so we can actually calculate va first. Okay, so u is equal to half ma va square plus half mb vb square, and you can substitute va first. Vb will be a half va minus half va. Okay, and then we get okay, and so half times 5 times 10 to the negative 3, okay, plus mb divided by 4, which is 0.01 divided by 4, okay, and then we have va squared. Okay, so just calculate some group the terms. Okay, so you have 0.225 joules is equal to 3.75 times 10 to the negative 3 va square. Then so va square is equal to, or va is equal to 0.225 divided by 3.75 times 10 to the negative 3, and then take the square root. Okay, so and you get 7.75 meters per second. That's for va. Okay, then for vb, okay, vb is negative half va, so you get negative 3.87 meters per second. So here are the velocities. Of course, if we are talking about the speed, okay, speed of sphere A, okay, the final speed of sphere A is 7.75 meters per second, and then okay, the final speed of sphere B okay, is equal to 3.87 meters per second. Okay, so here are the answers for part C. Okay, and that's all for this question.